First up on the list, and probably the most important if you are using building plans, that would be to verify all of the measurements. And I know that sounds like a no-brainer. Oh yeah, that's right. Or it might sound like, wait a minute, I paid a professional architect to draw these plans and it cost me $40,000. Everything should be right. Well, you're absolutely right. It should be, but it might not be. And that's the problem. Double check the measurements pertaining to all of the walls above and below. Double check and make sure the length of the stairway is actually going to fit in here. I can't tell you how many times I came to a project like this and the architect might have had a 109-inch total overall floor height difference. The measurement between the bottom level and the upper level, let's just say, was 109 inches, when in reality it was 112 inches. So this would have changed the step or the riser and then made me add another step because it wouldn't have fell into the local or met local building codes. So double check all these measurements. And I will put a link here for those interested in. I actually have another channel that I'm taking apart this house right here and showing you step by step. I'll put a link here to the stairway part of that video. Number 2 on the list, and this is probably one of the biggest mistakes professional stair builders make. They do not pay attention to the details. And again, if you're a perfectionist, you are going to be paying attention to the details. This was a lesson that it took me probably 2 or 3 years to get to realize how important it was. And that is that if you want your stairs to start and stop at an exact point, then each one of these treads need to be laid out accordingly. So here we have 7 treads and we have a 70-inch measurement. And if I was to lay each one of these out at 10 inches, I'm not going to have a problem. It's going to stop right on the money. If one of these is a 1/16 of an inch longer, or a 1/16 of an inch shorter, or a combination of both, a 1/16 of an inch longer, and then an 1/8 of an inch shorter, an 1/8 of an inch longer, an 1/8 of an inch longer, something like that, we're going to get some wacky measurements. So each one of these treads and risers needs to be laid out precisely, exact measurements. If you are dividing 5 foot, if we have 5 foot and we have 8 risers, we divide this into here, we're going to get 7.5 inches for each one of the risers. We need to lay them out at 7.5 inches, not 7 5/8, not 7 3/8, not 7 5/8 on one and 7 5/16 on another one. Each one of these needs to be exactly the same. And on longer stairways, it's going to be even a bigger problem. Number 3 on our list will be adjusting and compensating for building materials at the bottom and top of your stair stringers. And again, you're going to have to do this when you're laying out the stair stringer. So if I don't subtract the thickness of the tread off of the bottom of the stringer, I'm going to end up with a taller riser overall. So we've got to subtract the thickness of the tread off of the bottom of the stringer. And again, I'm just saying it. I'm not going into a lot of detail. I do have other videos on that. I'll try and find a link and put it here. And then of course the top. If you are going to add a riser, put a riser on here, everything will work out. But what if I wanted to butt the stringers, connect them to the concrete, and then have this be my last tread and then use the concrete as the face of my riser? I would just need to deduct the desired amount off of the stringer. Now, what if I wanted to add a ledger? If that's the case, I would just simply deduct whatever I needed for the ledger off of the stringer and then make sure that everything is going to work out accordingly. And here's what it would look like after I deducted 3/4 of an inch off of the bottom of the stringer. 6 3/4 of an inch provides us with a 7.5 inch finished riser, which would provide us with the same equal measurements for each part of the stairway. Number 4 on our list is another problem that most people don't even think about, and that will be the different size materials that you are going to use if you are going to use them at the bottom or throughout the stairway and of course the top. So if I go ahead and put an inch thick tile on the bottom and then put a 1/2 inch thick material over my stairway like this, I'm going to end up with a 7-inch riser at the bottom, and then the rest of these will be 7.5 inches, and the same thing at the top. Now if I'm going to use the same material throughout the stairway, let's say I'm going to carpet this area, everything's going to get the same carpet. I'm not going to have a problem. Everything should work out. But if you are going to use a thicker or a thinner material, either at the bottom or the top or on top of the stairs, you're going to have to compensate for those materials when you're laying out your stair stringers or building your stairs. Next up on the list, number 5, and this mistake right here will prevent you from wasting lumber, because what you're going to do is lay out a stair stringer and then cut it. And again, you could probably do this too by just laying it out and cutting the bottom and cutting the top and double checking everything. But if you lay out the stair stringer and you cut it, put it into place, put it into the position where it is going to go in the building. And then simply double check everything. Make sure that all the steps are level. The risers are plumb if they're not going to have an undercut on them. And then make sure all of these measurements work out. Make sure that you've allowed for the ledger. Measure everything and double check it 25 times if you have to. Now, this is where you're going to notice if you did not use precise and exact measurements. So let's say that you divided everything up and you come up with our riser height of 7 9/16, but you made the riser 7.5 inches. That's going to create a tread that's not going to be perfectly level or perfectly flat. And of course, this is where you will see it. If you put the level on here and it's off just a little bit, I would recheck everything, measure your riser, measure the riser height and the tread width to make sure that everything is proportionately accurate, or as accurate as possible. I mean, if you're off a 1/16 of an inch throughout the entire measurement here, this should be right on. It should be close enough. You know, if you put the level on here and this thing is sloping down 1/8 of an inch, you might want to recut the stringer. If it's sloping up 1/8 of an inch, you might want to recut the stringer. If you only have a couple measurements that are off by a 1/16 of an inch, you might just leave it, and that's going to be close enough. So here is another one of those problems that stair builders seem to have a difficult time wrapping their minds around. And when I say stair builders, I think that would be somebody who might not have a grasp on the art of stair building. Now, before I get started, I want to point out that I already have a couple of books written that will be helpful for those of you who aren't quite wrapping your mind around how in the heck you can center the steps on a stringer. And definitely recommend checking that out. Now, but for those of you who just need a little more information, hopefully you will find it in this video. So let's go ahead and take a look at the stairway that has the treads at the front edge. And I really don't like this. This is not something, you know, I like them centered. They look a lot better. And I can't tell you how many times I've seen a stairway built like this, where the person laid out the stringers, didn't double check any of their measurements, and these treads are sticking past the edge of this about 1 inch. So when there's plenty of room at the back, here we can see we can move this further to the back. But either way, this is a personal preference. If you want this look here, you know, you like this look, go for it. Lay it out accordingly. If not, push the treads back. And again, this is all in the books, either one of the books on how to center the treads. But the main point is, and the reason why I made the video, is to explain that either the treads need to move back or the stringers need to move forward. And I know this is difficult to wrap your mind around, but this needs to be done during the stringer layout phase, the design phase of the project, and not after the stringers have been cut. So if we take a look at the two different stringers, all three of these stringers are the same, but this one here is different because I moved the treads back and I added a little bit to the stringer here. So again, these three stringers are the same to give you an idea what I actually did. So I just added more material to the stringer to make everything work out. So move the treads back or move the stringers forward in this direction. And again, like I said, in the book, you will have everything you need to figure this out. So this is just providing you with an idea of what it would look like or could look like if you have a situation like this where the treads are at the corner and of course this one here where the treads have been moved back. Now another problem that I run into often is that there won't be a nosing on the landing or the upper floor, and hopefully this will make sense when you look at these triangles. So if we take triangles, or you can use your framing square to figure this out, the measurement for the tread is going to be from the face of the tread of the lower tread to the face of the upper tread. And this measurement in our case is going to be 10 inches. So if we did not put a nosing on here, we would have an 11.5-inch tread, not a 10-inch tread. So we need to put a nosing on here. And is it a big deal? I've walked up and down plenty of these stairs, and I never tripped down them. I never fell. So is it a real big deal? I don't consider it to be one. But your building inspector might not share the same feeling as I do. Now, another thing, when you build stairs like this, I can't tell you how many times I've came across this. Stair stringer comes all the way down, and it's a trip hazard. People come around the stairway. They're walking from this direction. They're making a turn. They got to step over this thing. You got groceries in your hands. Bam, you're tripping. Or coming down, same thing. Cut it off like this. This is going to reduce the safety hazard for people tripping, and I think it looks better. I actually think this stringer looks better than this one here, or even these over here. So in this video, I am going to talk about something that is probably irrelevant to most stair builders, but something I'm going to mention anyway. And that is just exactly what a flight of stairs is. What is a flight of stairs? Is a flight of stairs an individual section of the stairway in between floors and landings? Or is a flight of stairs in the entire unit of stairs? So in this, it has to do with a landing, obviously not with a straight run set of stairs. But if you have a landing in between floors, so we have the lower floor and the upper floor, and then we have a landing in between. Is this a complete set of stairs that should have the same riser and tread depth, the same width? Is that what this is, or are these two separate flights of stairs? And according to page 278 in the International Building Code Book, 2018 International Building Code Book, it actually says that a flight of stairs is basically a unit of stairs between a landing and a floor. So this would actually be an individual flight of stairs, and this would be another flight of stairs. So first flight of stairs, second flight of stairs in this situation. Now you're probably wondering, what is the big deal here? Who cares, if it's one flight or if it's two separate ones? But this is where I think it's something that could benefit you in the future if you are a contractor architect, someone who's not real familiar with the building codes, since it states that a flight of stairs shall have a landing at the top and the bottom. Flight of stairs, landing, floor, landing or floor. Then basically you could change the depth of the tread and the height of the risers. So this stairway here could have a 7-inch risers. This one up here could have 7¼ inch risers. And you're probably still thinking, what? I'm going to build the stairway with the right height risers. You know, they're all going to be uniform and the same. I got you. I got you on that. I would too. But if you were coming to a situation where you had a stairway somewhere, and then maybe you had a door. So let's say you had this was the front of your house, and you came up to the sidewalk, went up the set of stairs, and then you had a landing or a porch, for example, and then you had a door that went into apartment number 1. But then you turned and went up another stairway to apartment number 2. And this had 7-inch risers, and this one here had 7½ inch risers or 7¾ inch risers. Then this could be a problem. But it's not going to be a problem if your local building department interprets this flight of stairs as a separate one from this one here. And that's the point of the video. You're going to need to check with your local building department, architects, engineers to verify this information. I'm not going to say that my interpretation is written in stone, but it could actually provide you with a way to solve a problem if you're working on a project that where this information could be beneficial. So here's a video that I've been wanting to make for quite some time. I went down to the dollar store and bought 9 items. The reason why I did that was to keep it under $10 so that I could put that in my title on the video. If it would have been 10 items, then I would have had to put $11 in there. Wouldn't have sounded as good. So maybe I'll put $9.99 in there and see if that works. But for $1 each one of these gloves, I've seen these in the store for $6 or $7. Rollers, $3 or $4. Level, you know, what's that? And this looks like it's a 1-foot level for $1. This might not be the high quality item. You know, it might not even be level. I haven't checked it. Sandpaper, again for $1. Stuff that, you know, if you think about it, these are all items you could put in your toolbox if you're a contractor. Rope, someone else on the job might need it. A drop cloth. Paintbrushes, and of course paintbrushes, you know, for $1. This one here, I'm guessing in the store it's going to be at least $5. And you know, some of these are just hard to wash. You might be using an oil-based paint, and this is going to be the way to go here. And just chuck it when you're done with it. Caulking for $1? Come on, you can't even get it. I don't even know if you can get it for under $3 anymore. So that is it for my video. Check out your dollar store if you're looking for some items that might save you some money. And I would also suggest checking out your dollar store for other stuff. I was shocked. I've been going to dollar stores probably for about 10 years now, and I'm shocked to see stuff into the store that's $1. I was in there the other day and they had a gallon of bleach for $1. In the store it's almost $4. So, you know, check it out. This is going to be the first video. I will make a series of videos. I don't know how many, but I kind of want to break down the reasoning for placing stairs where they might do a little better in a particular home, and the reasons why. So let's go ahead and get started. This particular stairway seems functional. It goes up a couple of steps to a landing and then up to another landing and back up, and it's close to the kitchen. This is definitely a plus. You want to be close to the refrigerator, want to be close to the front door, the garage, a bathroom, and of course the bedroom. So for those of you who aren't quite grasping this, you're not real, I can look at a floor plan and kind of see what's going on. Let me go ahead and go to a different view here. Okay, here we are. We have our master bedroom here, a bathroom here, our stairs, 2 bedrooms. Just kind of want to go around here just to give you an idea for those of you that aren't getting it with just looking at the floor plan. So here's kind of what I'm thinking. You go downstairs, you're in the bedroom. You've got, you're a little thirsty, or maybe you got to leave, you got to go get in your car. So you're way over here. You're going to go down the stairway, and then let's go down the stairs. I switched the levels here. Down here, you're going to go into the garage. You're going to go into the kitchen, get a drink. Maybe you got to go through the front door, go get your mail, something like that. The point I want to make here is that the stairway needs to be as close to important rooms as possible. Needs to be close to the front door. Front door, you're up here, the doorbell rings, you come down here. And again, this is an excellent layout. In some of the other ones that I am going to design, I will give you some more ideas of the farther away you are, the more exercise you're going to get in. And again, if you don't mind exercising, knock yourself out. Put the stairs wherever you want. If you're somebody who would like to make everything as convenient as possible, pay attention, because the front door is important. The garage access is important. A bathroom is important. And of course, the refrigerator is usually going to be important. You're in the living room going to get a drink or something like that. This stairway is not going to be a big deal. You're upstairs and you're in the bedroom here, and you got to come down the stairway to get a drink. It's going to be. And again, this is a good layout. This is a good layout. The only problem I have with this particular stairway would be to make sure that, or concern, would be to make sure that you have enough headroom here for the stairs that come up. So here you can see we have 2 steps. And if I go downstairs, we actually have 3 steps. So in an 8-foot tall ceiling, this could actually, I'm sure it's going to work because I already drew this up here. So it should work fine. But it could be a concern if you're going to come down 4 steps, for example, or try to move the floor over a little bit. So back up. Back up. So if we were to move the floor over to here, not going to work. It's not going to happen. So the floor might have to move back a little farther depending upon your stair design. So that's concern number 1. Concern number 2, anytime you got to turn, and here we have 2 turns, you might have a problem getting furniture up here. So if you have a handrail on the side, let's go back to the view here. So if you have a handrail here, and you are going to try and move a large dresser up here and make a turn and stuff like that, it might not happen. So those are my only 2 concerns with this particular design is for the stairs. I like the stairs. They're in a good location. And when I say it's nice to have them centrally located, they can actually be off to the side and still be somewhat centrally located in smaller homes. So I'm going to go ahead and stop right there. I will put links here, and I'll put a playlist together when I get videos, more videos made in the future. But what I would like to do, my grand plan, is just to put together a few videos that will get you thinking about just exactly how important it is to position a stairway in a building or a home. And, you got to keep in mind convenient rooms. This is very important. Doors, bathrooms, refrigerators, right? This is very important. So if you just watch this video, you should get the gist of it right here. You're not quite sure, you need a little more, then go ahead and watch the other videos I make in the future. In this video, I am going to provide you with another idea. I will put a link at the end of the video with another method for figuring the height for a stairway. And I have one where you're using a bunch of stakes. You're going to drive some stakes in the ground and kind of use a water level or a level to figure the different heights until you get to the top. But in this one here, I think we can do it with a string and a couple of stakes, and it should work for any other types of, if you have a different type of hill. Now the reason why I'm making this video here is because someone said they had a really steep hill and it was rocky and they couldn't drive any stakes into the ground, and kind of came up with this idea here where you can use a string to figure out the angle and then figure out how many steps and how tall the risers are going to be. And it's relatively simple, but I do understand that since I kind of figured it out, I'm going to have a better idea of what's going on than you do. And if you do have problems with this example here I'm using, feel free to share your problems with me in the comment area and I'll see if I can help. So basically what we're going to be looking at will be to try and figure out the hypotenuse, or the longest part of a right triangle. And in order to do that, you might need to actually raise the triangle, the base of the triangle, the line you're going to be using for the straight line up. And in this case, we raised it up about 30 inches. And I just kind of wanted to give you an idea of what I'm doing here. If I was just to draw a line from here, or try and create a straight line from here to here, where I want the stairs to start and stop, I'm going to have a part of the hill in the way. So in order to do that, we're going to need to drive some stakes in the ground and raise them up to where we can't, or should I say won't be, hitting the hill at any point, so that we can create a nice straight line. So basically this right here, I just kind of put it in here as an example. This is what you're going to be doing. You're going to be getting two stakes and driving them in the ground. Now these stakes will need to be level. Otherwise you will have problems when you are figuring out your angles or your line you're measuring. If this is leaning an inch this way, you're not going to have the exact measurement here that you need to create the stairway. So this stake and the lower stake needs to be vertically plumb. And of course, we will attach another piece of wood to the stakes, drive another one into the ground, make sure that this one here is level. This is going to be a guide for your framing square. And you can simply slide your framing square in either direction you need to kind of figure out what the length of a riser could be, or the length of a step. And you can do it by simply dividing the length of the string into certain increments. So for example, if you have a total length, and I already figured this one out here. Let me pull up the notepad here. We have 31 feet, 7.5 inch hypotenuse. That's the length of the string. And if we divide it, we can divide it by any numbers, but I divided it by 16 because I already did the math here. So the overall length in inches, 31 feet, 7 inches is 379 inches, 0.5. We divide it by 16, that gives us 23.72. 23.72 is basically 1 foot. If you think about it, it's a quarter inch less than 2 feet. So our numbers are pretty much right on here. So it's going to give us a 7.5 riser and 7.5 inches and 22.5 or 22.5 inch tread. So take that away. You can go back and look at it if you need to again. So what we're going to be doing is taking the length of the string from here to here. And if for some reason you can't measure the length of the string when it's in this position, simply take the string, cut it at the point where you had it at, and then take it down to a horizontal surface somewhere, someplace flat, and then measure it down there. So if you have a real steep grade, something like that, then you're probably going to need to measure it somewhere else if you can't climb up the hill, or I don't know what the problem would be. Just kind of throwing out another idea there. So this is our angle. Remember, we're up 30 inches. And of course, here is our stairway. We have 16 increments in here. Feel free to pause it and pause the video, stop it, and count them if you want to. Each one of them will have a 22.5-inch deep step, tread, and a 7.5-inch riser. Another view of it there. Remember, it is off the ground. You've got to keep this in mind when you're working with this. If you raise it up off the ground, you need to be able to subtract it somehow. Don't start excavating or doing something and then realize you got to go down another 4 feet or something like that. So very important, whenever you raise it off the ground, you're going to need to somehow lower it into the dirt, into the soil, or build something, build some type of a platform to make everything work out. You can always build a raised deck here. So here we can see how far off the ground we are. And this gives you an idea of what the stairway could look like if you built a straight stairway using this method with the straight line and then breaking everything into increments. And then, of course, using the level and the guide board here to figure everything out. And if I wanted to add another step to this and lower the riser, I could do it by simply dividing instead of dividing it into 16 increments, I could divide it into 17 increments or 18 increments if I want to make my treads a little smaller, and of course just refigure the stairway accordingly. Now in this example, I went ahead and lowered it into the ground to give you an idea what it would look like, and of course how much soil you might need to remove. So this right here, you've got what's important. You've got the line to figure it out, but you're also going to need to connect a line, something from here to up here. And to do that, to get a straight line, you might need to start removing some of the hillside. And of course, this might also give you an idea of, you know what, if I have to remove 30 inches of dirt here, you might not even want to build the set of stairs, or you could always move it forward, backwards. You might be able to raise the height of it, something. But here you can see where we moved it forward and created a longer walkway here. And then simply, we don't got to remove any soil, but we're going to have to install some type of supports probably to make the stairway a little stronger. So that is it for the video. The main reason why I wanted to do it was to give you an idea about using a string and a couple of guide boards with a framing square to figure this out. There are other math formulas you can use. If you're pretty good at math, then I probably don't need to tell you what those formulas are. If I ever do make a video with those formulas, I will attach it to this video. But I think this right here simplifies everything. The method that I outlined in the video creates a fairly simple method that makes it possible to build a set of stairs on a hillside and give you an idea what the tread depth is going to be and the riser height. In this video, I will provide you with some much needed information for anyone who is planning on adding a nosing to an existing stairway. So if you have a stairway like this, you do not have a nosing on it. But this one actually does. So here is an existing stairway, or a stairway built with a nosing. And a nosing is simply a projection off of the front of the riser, usually around an inch. I believe most building codes, 1 3/8 of an inch. 1 3/8 of an inch is the maximum a nosing can project. Now, the first thing I want to point out, and the main reason why I'm making the video, is most of the time when people walk up a set of stairs. They're not going to just be putting their feet flat on the steps and walking up the stairway. I'm not going to say that they don't do it, but if you pay attention to how you walk up and down a stairway, you're usually putting a lot of pressure on the front of the nosing area. And if you're going to add a nosing to it, this is going to, or could be a problem if it's not assembled properly. So you can see here, you're going to be using an area between this distance and this distance when you're walking up a set of stairs. You're kind of going to put your foot on the front of the step and then set it down, proceed up the stairway. And that, of course, like I said, is going to create a lot of problem for the nosing. I've even seen lumber like this made out of particle board. I'm not saying OSB or plywood, but I've actually seen particle board used for stairs like this, and it just breaks off the front because it's not structurally strong enough to support the load. So 3/4 inch OSB or plywood, or even hardwoods and softwoods, you're probably not going to have a problem if it's a solid piece of lumber. So if you just simply add a strip of lumber to the stairway to create a nosing like this, there's a very good chance that the pressure from someone using the stairway, and again, this depends on how many people are going to be using the stairway. If you just have one person using the stairway and they only go up the set of stairs once a year, you're probably not going to have a problem. Any more than that, you could have a problem, because all it's going to take is one person to step on this, to put enough pressure on it to end up with something like this. And again, it's not going to take as much pressure as you even think to break something like this off. And I'm not suggesting you can't do it a different way. You can't glue it. You can't put 300 screws in it or whatever. Fine, give it a shot. But be warned that just by simply putting a strip on the front and a couple of nails or screws, it's not going to last very long, or at least I'm suggesting that's not going to be the best method. So as option number 2, you might want to use a larger board, something like this, where you can have a larger area to attach to the existing stairway. So a real small, skinny piece of wood, you're not going to be able to put a lot of screws in it, and you're not going to have a lot of surface area for the adhesive if you're going to use some type of a glue also. So you can glue and screw it or staple it, whatever you feel like is going to work. But don't forget, this idea here is going to provide you with a different type of nosing finish. So if you're going to carpet a stairway like this and you want to have a smaller nosing, this one here might not work. Another option would be to take a solid piece of wood and cut a shape to it that would work for your particular nosing. Now, the only problem I would have with this is that if the lumber wasn't a very strong piece of wood, it could break off on the nosing. You could have, if you had, let's just say you had the grain of the wood running in this direction, and someone was to step on the edge of it, it could actually split it. So this right here isn't going to be the best option. Using soft wood might be a better option with hardwood. But I also need to point out that you would need to do something like this to the entire stairway. If I left one of these out at the top or the bottom, for example, and let's just pretend like this is the top of the stairway, and I left this one out, and I added 1.5 inches to this, I'm now going to have a step that's 1.5 inches longer. That's not going to make the building inspector happy. Another option, of course, will be to remove and replace the tread. So this, you would simply remove the tread without the nosing and replace it with a tread that does have a nosing. Now, if you do have a stairway that is not wedged in between a couple of walls, and you can actually take a saw and cut the entire width or length of the tread here, in that case, you can simply cut a section of the tread and then block it. Now, if you don't install the blocks, you're going to create a weak spot here. Let's just go back here. If I just put a board in here and then replaced it with, or the section that I removed, installed a new board here, there's going to be a weak spot in between the stringers. So this is going to be a weak spot here. So you're going to need to install a block, some type of blocking in here, so that you can strengthen this area. So again, another idea, but this one here is probably not going to work as well for a lot of people, because most of the time a set of stairs is going to be built in between a couple of walls, and you're not going to be able to run a saw all the way across. Another idea, if you could, and again, this is just going to provide you with a little more strength, but you're still going to need the blocks. I think if you install the blocks, you're really not going to need to do this, but you could cut an angle on the existing tread. Cut it back. Do not have it like this. If you have the angle cutting back this way, and you put pressure on the front of the tread, so you're standing on this, you're putting pressure down on the front of the tread, it's going to want to lift this up. Well, if you have this angle cut here, it's not going to allow it to come up. Now, if you have it in this direction here, and you put pressure on the front, then you can see here where the front of it will lift up. It's not going to be wedged in between this area here. And of course, my last option will be to use some type of dowels or a biscuit joiner, something like that. And you could simply drill your holes for your dowels into the existing tread, and then have the same holes match on the other side for the trim piece or the nosing piece you're going to put on. And this right here just might work fine. Now remember, with something like this, you're still going to be putting a lot of pressure on these dowels. I don't know how many of these dowels you will need, or how many biscuits if you're going to use that, or other materials for something like that. So that's it for the video. I hope it helps. Just keep in mind that main reason why I made the video is to point out that you're not just going to be able to nail a small board on here and carpet around it, or put something around it and have it last forever if you don't reinforce it somehow, or use larger pieces of wood for that, or even in that case replace the entire tread with a tread that's a little wider, so that you do have a nosing and you don't have to worry about any of this. In this video, I will provide you with an example of how to build a simple bridge, how sturdy it will be, and stuff like that. Structurally strong remains to be undone. I've never built one of these in person. But there is more information on the internet. Simply type in Da Vinci Bridge. This is, according to some of the books I've gathered the information from about building it, it is from Leonardo da Vinci himself. So whether it was invented by somebody else, I cannot guarantee that information. But I can tell you that the bridge seems like a pretty good idea. Now, you can always use larger lumber, and smaller pieces. These are 12-foot 2x4s and 4-foot 2x4s. And this bridge just might not be that sturdy. You might need to use smaller lumber, maybe 8-footers. And they might need to be 4x6s or 4x10s or 6x12, something like that, if you're actually looking for a bridge that's going to be pretty strong. So let's go ahead and get started. And we're going to start with the 2x4s on each side with a board in the center there, and simply place a couple of more of the boards next to them. Then we will simply raise the boards over here, each one of them, and slide a 2x4 underneath them so that we have something like this. And we currently now have our first bridge. This is, if you just needed to get something here, you could probably do this. And remember, these are 12 feet, so this is probably about I'm guessing a 14-foot span here. Now, if we want to make it a little longer, we will simply just continue to add boards to the bridge. And I just want to show you the gap here. There's a gap between the boards because of the boards we're going to be using in the other directions. And again, all this stuff can be screwed, bolted together after you are done or while you are working on it. So here's the next step. We have our bridge, and then we're just simply adding a couple more boards here. Then we will simply raise this section of our bridge and then set it on top of another board that will be sitting on top of the two boards we just added here. Again, to give you a view around of what the gaps are here, and then the boards that are kind of sticking past a little bit. And I know some of you are going to have a tendency, you're going to want to pull these boards in. I would keep them straight, keep them parallel to each other. That way you can, it'll help you when you start installing the next boards for the deck on the bridge. So again, you could actually stop here. If this is the length that you wanted for your bridge, you could stop here. And again, if you could just imagine these being 4x4s instead of 2x4s, they're going to be a little stronger. In this example, we are going to do things a little different. It might be easier for you to assemble this with the boards actually attached. The bracing board, if it was attached to the side boards here, just simply screw it or nail it to the other boards and make sure that it is in the correct position. That way you could simply just pull it in, lift these boards on top of here, and then take these boards here and set them on top of this one. And of course it would look something like this. So this would be the section that you would prefab. You would just nail this together and then just simply slide these two side boards on top of your brace, support brace, and then simply pull these up and over onto this brace. Another view of it there. And again, this is quite a big. I want to say this is about 25 feet, the span of this right here. And after you have attached everything, all of the sideboards to the support braces, you can start to install your decking. Now, here I just took some 2x4s and I think I put them about 6 foot on center. You could always put them right next to each other. The reason why I made this video is because I found plenty of information on the Leonardo da Vinci Bridge. I just didn't find where they had anything showing how you could use it as a functional bridge. So, you know, they had a couple of things where you could jump from support brace to support brace, but this right here ought to give you a better idea of something you could actually walk over as long as it was structurally stable. So, and you might be able to do this with smaller boards. You know, these are 12 footers. If you cut these in half and use 6 footers, you might be able to make a stronger bridge also. So I'd imagine the longer the boards and the skinnier the boards, the weaker the bridge is going to be. Smaller the boards, going to be a little stronger. But if you may use larger wood, like I was saying, then you could end up with a pretty good bridge, something that you're not going to be driving a truck over, but something you could walk over. Okay, here is a method that you can use to make a square line with 2 circles coming off of these corners. The only thing you're going to need to do will be to make a mark somewhere. So I could make this at 8 inches. Put this where I'm not in the way. I could make this at 8 inches. This measurement over here would just have to be the same, 8 inches. Now, I have these 2 screws at 9 inches. And all I need to do is use a circle and then draw a line across it at these points that connect. So I'm going to come over here. I got a 14-inch space here. Try and get out of your way there. I'm going to just go at 9 inches. I'll go at 10 inches. 10 inches, circle, 10 inches, So we can see I have a point here. And again, I'll go 10 inches down here. 10 inches. Come over here and go 10 inches. And this you can see a little bit better. 10 inches. And then I simply draw a line through these 2 points here. But instead I'm going to use the square and just square it up. And you can see right there that that is a square line. So if I didn't have a framing square, all I would have to do was grab a straight edge, connect these dots, and this would be a square line here. Now let's go ahead and use a full sheet of plywood. Something like this could come in handy if you are going to be doing building foundations, odd-shaped building foundations. Actually, I was going to make another video to provide you with a exterior building foundation that wouldn't have any 90-degree corners, and that would be difficult to create a straight line on the inside, but it won't be, or I should say some lines that you can use to have all of the interior walls square and parallel to one wall or perpendicular to it. So we're going to start up. Here's a square piece of plywood or OSB. Here is one with, we got some different angles. These are not 90-degree corners. But I wanted to start by showing you the circles already drawn, straight line, our 2 points. I believe these are 10 inches. It's a 10-inch radius. And then, of course, our line down the center. So this is what it would look like if you just drew 2 complete circles instead of just coming from here and then making a 10-inch arc, and then over here making a 10-inch arc to get the lines. So let's go ahead and start with a blank slate. Measure in a foot. Draw a straight line parallel to the edge. So 1 foot, 1 foot away from the edge. And then you can place your lines anywhere along here, as long as they aren't too far apart to where when you draw your circle, it's not going to be off of the plywood or the OSB. So for example, these are 16 inches apart. And if I drew them 40 inches apart and then had to draw a 20-inch or a 30-inch circle, you could see where I would be out here somewhere, and it wouldn't be good. So just keep that in mind. I mean, that will be one of those things that you, if you draw it, you're going to realize, okay, I got to move these things closer together. So here's our first circle, 10 inches. It's a 10-inch, this is the center point, 10-inch radius, 20-inch diameter circle. Another 10-inch circle. They've got to be the same size. So the crucial part to this particular idea is a parallel line from one of the edges, something that's straight. And then the lines here can be farther apart. This isn't going to matter, but the line needs to be parallel to one edge, and the circles need to be the same size. So if I had a 9-inch radius or an 11-inch radius, it would still work out because the lines would cross over where the line here would meet. So if I had a, let's just say I had a 12-inch radius and it took me out to about here, and this one here took me out to about here, I would still be on the line as long as the circles on each side are exactly the same. So there is our line that is perpendicular, 90-degree angle. So we got a parallel line from the edge, and then a line here that we could use if we wanted to as a guideline. So we could continue this line all the way up. And I think I'm just going to go ahead and do that. Continue it all the way up. And then all you would need to do would be to measure over here. So if this was 8 inches, you would just come down here and then make a mark from here, 8 inches, draw another line, and then you could cut that, and then you would have a square edge for your plywood. So anyway, this is just another tool to put in your home building toolbox there. And trust me, Something like this might sound like a lot of work, but it can save you a lot of time and grief if you are starting out with lines that aren't perfectly flat, perfectly straight, or buildings that are wacky with no 90-degree angles on the outside, and you need to actually create 90-degree angles and parallel walls on the inside. Here is another video that was requested by a few people over a long period of time and thought it was time to make a video. I'm actually going to provide you with some ideas on how to build a landing, or support the landing, I should say, on a concrete floor. And a lot of these stairs are built, and I can take you to plenty of them. And the stair treads do not line up. And in this one here, they actually line up. The stair stringers are not going to change positions, but the landing supports will be framed differently. So just to give you an idea of what I'm talking about, the front of this tread on the upper stairway lines up with the nosing or the overhang in the landing. The second tread, the front of the second tread, lines up with the front of this tread here, the next tread that would be up to the landing. I just kind of wanted to throw that out there. These stairs are not that difficult to build, but I do understand where the landing supports can be a problem or confusing. And like anything, if you know how to do it, it's easy. If you don't, then I think this video is really going to help you out and provide you with some ideas on that'll help you if you're going to build a set of stairs like this. So this set of stairs right here is going to come up to a doubler. We're going to use a double 2x10 here, and a couple of support boards underneath it. Just frame a simple landing here. I think we're using 2x10 joists, and you can attach them to the wall. You can use hangers, end nail them, toenail them, pressure blocks in, and our landing. Now here's something I just kind of wanted to throw out there. You can see if you're coming up the stairway, and if you have a landing that is 36 inches from here to here, and you have this in the way, the building inspector is not going to like it. You might have to cut it off even, or flush with the front of the stair tread. Just kind of wanted to throw that out there. Another thing that is confusing with these types of stairs, laying them out. I understand. I have seen them. You can go up to, I can almost guarantee you can go up, if you come across a set of stairs like this, you can look at the landing, and these treads are not going to line up. It's just too hard for most stair builders to figure it out, or whatever they're working with, I have to say. So in this one here, we are going to have a doubler supported by the post that goes all the way through. And then we're just going to simply build a wall here. You want to put double top plates on, knock yourself out. But this wall is going to provide us with some support for the upper stair stringer, and allow us to have the floor sheathing go a little bit farther, so we actually have something to step on. That's another problem I've seen quite often. Now in our next example, we are going to just change the doubler to a beam there to, if you're looking for a little more support, or the engineer might even require a beam instead of a doubler. So same wall framing, just a beam there instead of the doubler. Now in this example, we are going to lower the beam, and the reason for that is so that we can cantilever the joist on the other side. So here we have the beam that runs all the way across. Supporting post. Take a look at a view from the other side. Same thing. We can see here where the joists are cantilevering a little bit. Makes sense, right? We've gotten rid of our wall. This might give you an idea if you need closet space underneath here. And keep in mind that most of these stairs need to, or I should say, they're going to have the risers closed if you build a set of stairs like this on the inside. But again, the video's not about that. There's more information about that in the book, and I recommend you getting the book. Watch the video. Everybody who watches the video, go get the book, and then maybe I'll be able to retire. Oh, wait a minute, then I wouldn't be making any more videos, so forget that. Maybe just half the people buy the book and the other half maybe buy another one of my books. How's that? So again, we're looking at the same situation here, kind of giving you a view of this one here that's sticking out. But that's not the reason why I came here. This is the reason. Let's remove the plywood and the stairs. And you can see here where the joists are cantilevering a little bit. And I doubled these up. You might not need to double them up, but it seems like it would make sense. Double them up to support the stairs. These are some heavy stairs. They're not like or I should say they're a little heavier than stairs where you're cutting 2x12 stringers, kind of a conventional set of stairs. But here we can see where landing works out, give you an idea of what this looks like. Put everything back together. And this is probably going to be the most common method that would be used, and that would be to simply frame a wall and offset the walls. You don't need a wall to be continuous and then a shorter wall. Just have two different walls in there. Same height, of course. See where they're offset. And they are supporting the floor joist just fine, or the landing joist. Another view of it there. Without the sheathing, an idea, we're still using our doubler here. And you might not need to use the doubler on this one. You're going to be, with a cantilever, the doubler is a good deal. With this one here, you're still going to be getting a lot of support from here with the wall and transferring, the weight would be transferring down to the wall, of course, through the joists. And that is it for this video. So I hope it helps. And again, if it does, you like these videos, you want to see more of them, hit the old thumbs up button. If you don't hit the thumbs up button, I'm still going to make these videos anyway, so don't beat yourself up over it.